So continuing with our activity or lecture. So in this case, we will now proceed with the service function 0h of the 0AH of the interrupt 21H. So for an example, we have here 10. So 10 here is in decimal and 0AH is in hexadecimal. Now, so again, the data register will contain the memory location, so the address of the string, okay, represented by the num. Okay, however, it's different from regular string declaration. So in move AH9, load effective DX string, what did we do there? So for a review, so we have E at memory location 100, and then we define the content of that as rosemary, correct? So in this case, whenever you use an input string, we will still define a memory location to save that particular string. However, you have to specify the size of the string, the initial actual size, and then the address of the string to be inputted. So for that, for example, we have here at memory location 110. So this is the input string. So the first byte will be the maximum size. The second byte will contain the actual size, and the third byte will contain the string to be inputted. So again, this is the maximum. This is the actual size of the string to be inputted, and this is the address of the string to be inputted. Okay. Okay. So let's have an example. Okay, so in this case, I will assemble, so let's say enter at memory location 100, I made a mistake, so enter at memory location 100 the string rosemary, okay, and then we enter at memory location 110, so what is that, the maximum size, that is 20, the actual size, byte initially as 0, and the initial content of the third byte, which is the location where the string will be stored or saved earlier. Okay, so at this point, so let's display the content at memory location 100. So as you can see here, it already has the content. I'll just clear the memory location 1, 1, 2. So how do we clear that? So we fill at memory location 1, 1, 2 up to 11F with 0. Okay, so let's display the content of 100. So as you can see, it's now clear. Okay, so from 1, 1, because earlier it has a content, so it's now clear. Okay, so at this point, what we will do, we will assemble at memory location 100, okay, which enables you to input that string. So move AH, was that 0A? Why can we not choose? Why can we not use move move AH 10 here? Okay. Well, we cannot use move AH 10 here because by default debug contains hexadecimal value. So that's the reason why. Okay, so in this case, so in move, okay, sorry, so load effective address dx, the address of the string to be inputted. What is that address? That is 110. So we have the address that is 110 and then interrupt 21H. Okay. Okay. So content. So if you want to display the content of 100, okay, so it still doesn't have any content. So let's assemble. So let's R. Okay, so it's not pointing to the correct address, so we will be changing that to 120. So let's verify. So that's the correct address. So trace, okay, trace, and then interrupt 21H. That means we need to proceed. So now, as you can see, it has a prompt. Okay, so that means it expects an input. So there, let's input here Pellegrino. Let's display the content of memory location. As you can see here, Okay, so as you can see from here, the so it is the actual size. So this is the maximum size. This is the actual size, which is earlier that is 0, right? And the whole thing of here is 0. So as you can see, it inputted what values? It inputted the these given values. Okay, so P up to this one. So how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So 0D is what? Enter key. 13. Okay, so we have here the enter key. So that is 0D. Yes, 0D earlier. Now, okay, so if we would like to output the content, so we can assemble to continue. So we assemble, so it continues to memory location 128. So move AH9, okay, load effective address DX. What is the address of the P? Because this is what is our string, right? So what is that address? So that particular address is 110, 111, and 112. So that is 112, okay, interrupt 21H. However, this, okay, so as you can see, it will produce you an error. Primary, what is that? That is, it will give you garbage, right? So let's verify. So let's check our register. It points to the correct instruction. So trace, trace, and then proceed. Okay, so as you can see, it gives you the garbage. Okay, so now what do we do? So what can we do so that it will output the correct location? So let's unassemble at memory location 100. So we have to make sure, what did we do before? We have to insert end of the string. Okay, so we have to insert the end of the string. So where can we insert that? So we should be inserting that before we output. We should insert the dollar sign before we do the output. So that means we will assemble at memory location. So the address of this is 128. So at 128, assemble at 128. What do? We will insert the, so that means we have to go at the end. Wait. So if we will display 110, okay, that means we have to proceed here, correct? What is this address? This is 100, 101, 2, 3, 4, 5, 6, 7, 8, 9, A, B, and C. So at address C, okay, 11C, we should insert the dollar sign. Now, so in that case, okay, so how do we do that? We know already, okay, we know already that the start address is at what? So we know already that the start address is at memory location 112. We also know that the size of this will be A. So that means we can add 112 plus A to produce 11C. Correct? Okay. So how can we assign the 112? This is an address. And we should be able to get the address of 111, which is 112 minus 1. Okay. So in that case, let's just delete that capture one. Okay, so in that case, we need to, what do we need? So we need the address of this assemble at 128. We need the address of the string, inputted string. It was that address 112. So load effective address bx, the 112. Okay, that's the address of the string. So what we will do, we will add, okay, we will add the address which is in the bx with the content. So as you can see, okay, so let's explain this one. Okay. So in this particular example, we've already load effective address bx. What is this? This is the address of the string. So address of the string. Okay. What do you think will be the content of the bx? Okay. Will the content of the BX the address, or the content of the BX will be the letter P, so PE, okay, from the Pellegrino. So what is it? So it will contain the address, which is 112. Okay, now, so take note, the address of this is 112. Can I change? No, I can't change. Okay, so in this case, again, the content of your BX now is what? 112 or 0112. Okay. So in this next instruction, it means that you have to add the content of the BL. What's the content of the BL? This one with the content of the BX minus 1. What is our BX? That is 112. So BX is 112 minus 1, which is equal to 111. What is this 111? The content of memory location 111. So the content of memory location 111 is the 0A. So which means we will add this plus with 0A. And what will be the sum? So A, B, C, so that is 1C. Okay, so this will be the content of the BL, 1C. So 1C. Okay? Okay. So at this point, now since BL already contains the address, okay, so it points now to the address. What is that address? What do you think will be the address? That is 11C. Now we can now insert the string, the character. So move byte pointer. What do you mean by byte pointer? We will be only inserting 1 byte, since, so if you will do move bx 24, okay, it gives you an error because bx is a word. Okay, so move byte pointer, the memory location bx, okay, and the source is 24. Okay, so now we've already inserted the the dollar sign. We can now proceed move AH9. Okay, so load effective address DX. What will be the string? The string in memory location 112 interact 21H. So let's run. How do we run? So let's start with the let's rip at memory location 128. So let's see, is it pointing to the correct instruction? Yes. So the trace. So as you can see here, BX contains 112. So BX contains 112, which is the address of the string. Now we will be adding whatever the content of the BL with the content of BX minus 1. So BX minus 1 is 111, okay, which contains 0A, so trace. And then, so it now points to 11C, so trace. Now it adds, so let's display at memory location 110. Now it adds already the dollar sign, so we can continue. So trace, so move AH09, so trace, and then proceed. We have the Pellegrino. Okay, so we will be continuing with other topic